Welcome back to The Explainer. I'm your host, and today I'm putting on my elite data structures and algorithms coach hat. We are going to completely rewire how you see the binary search algorithm. Forget about just memorizing standard formulas or, grinding through code blindly. My mission today is to train your brain so that whenever you look at a brand new problem, you instantly recognize if binary search can reduce that search space and lead you straight to the optimal solution. Get ready because we're about to seriously shift your mindset.
Okay, let's just dive right into this. Why is checking everything simply too slow? Well, when you default to a brute force approach, like scanning an entire array one by one just to see if an element is there, your time complexity scales linearly. And if you're doing this inside a loop, you quickly end up with an incredibly slow algorithm. In a high-stakes interview, leaning on brute force right out of the gate is a massive red flag. It tells the interviewer you aren't instinctively reaching for efficient tools to manage really large datasets.
To put this into perspective, think about the sheer contrast in efficiency here. Brute force operates in O of n time, meaning checking 1 million elements could literally take 1 million individual operations. But binary search, it operates in O of log n time. It finds your target in 1 million elements in at most 20 steps. 20! And it gets even crazier. Even if you scale that up to 1 billion elements, binary search needs at most 30 steps. That's not just a small improvement, that is a fundamentally different category of efficiency.
So, here's our masterclass game plan for today. We'll hit the power of having, spotting the monotonic condition, essential binary search patterns, binary search on answer, and wrap up with beating the interview traps.
All right, starting with number 1, the power of halving.
Before we even think about writing a single line of code or setting up a loop, we really need to nail down the raw intuition behind search space reduction. Just think about a real-life analogy, right? Like looking for the word mango in a physical dictionary. You don't read page by page starting from the letter A. No way. You open it to the middle. If you land on the letter S, you immediately know mango is to the left. You completely discard the right half. That mantra, split, discard half, repeat, is the absolute core of the algorithm. By just applying this 3 times, an initial search space of 10 million elements instantly shrinks down to just 1.25 million. You are aggressively eliminating half the possibilities with every single comparison.
Moving on to section 2, spotting the monotonic condition.
Now this requires a complete paradigm shift. It is the secret weapon for dominating FANG interviews because it completely moves us away from just looking for numbers in a sorted array. A monotonic condition is a condition that flips from false to true across an ordered range and, crucially, never flips back. If an array is increasing, it won't ever decrease. This property is the absolute foundation for applying logarithmic optimization. Without a monotonic condition, binary search has absolutely no way to confidently know which half of the data to discard.
And this brilliantly illustrates how our thinking needs to evolve. We aren't comparing raw values directly anymore. Instead, we are asking yes or no questions. Is this index valid? Is this capacity feasible? Once those answers transition from false to true, they stay true. Binary search is simply the fastest possible way to find that exact boundary, that flip point in logarithmic time. It essentially turns an array of complex data into a simple, predictable sequence of falses and trues.
Next up, section 3, essential binary search patterns.
Listen, in a high-stakes interview, your pattern recognition speed is literally what separates a strong hire from a quick rejection. As your coach, I want your brain trained on these specific trigger words so you can spot the underlying pattern within 30 seconds. If you hear sorted array or a strict requirement for O of log n time, boom, that's standard binary search. If they ask for the first or last occurrence, you're looking at a lower or upper bound pattern. What about a rotated array with an unknown pivot? That's your modified binary search. And if they ask for a minimum capacity or minimum speed, that is the ultimate trigger for binary search on answer.
But before we tackle the really hard problems, I've got to highlight the bulletproof foundation of our code template. You should always calculate your midpoint as left plus right minus left divided by 2. Now, you might be wondering, why not just add left and right and divide by 2? Well, because this specific formula totally prevents integer overflow when you're dealing with massive array sizes. It's a super subtle detail, but writing it this way immediately signals true engineering mastery to your interviewer.
All right, section 4, binary search on answer. Consider yourself warned, because this is where the difficulty spikes dramatically in big tech interviews. As ex-Google interviewers will frankly tell you, this pattern separates junior from senior candidates. It tests if you can optimize a problem that doesn't even look like a search. Think about that. In these problems, you aren't searching through a given array of data at all. You are searching through the entire space of possible answers. To conquer these beasts, you gotta stick to this universal 3-step framework. Step 1, define the search space. What's the absolute minimum and maximum possible answer? Step 2, write a true-false feasibility function. Like, can a candidate answer actually satisfy the problem's strict constraints? And step 3, verify monotonicity. Does that feasibility flip only once? When you're in an actual interview, state these 3 steps out loud. It proves to the interviewer you have a systematic, senior-level approach, and you aren't just copy-pasting memorized code from some tutorial.
The real magic happens when you visualize the efficiency gain here. Take the famous Coco eating bananas or ship packages problems. A brute force approach would have you guessing every possible eating speed or ship capacity linearly, which takes O of n times m time. But by binary searching that answer space, we optimize this completely down to O of n times log m. You just guess an answer right in the middle, run your O of n feasibility check, and if it works, you instantly slash your search range in half. It is just a massive, massive leap in efficiency.
Finally, Section 5, beating the interview traps.
You know, understanding the theory is great and all, but executing it flawlessly under extreme time pressure, that's where a lot of solid candidates stumble. Studies actually show the majority of professional programmers introduce a bug in their very first binary search implementation. Here are the most common interview killers: the dreaded infinite loop, conflicting boundary updates, setting incorrect initial bounds, and checking the wrong half in a rotated array. I want you to frame these not just as minor coding bugs, but as major negative signals you might accidentally be sending to your interviewer.
Let's talk about the infinite loop trap. It happens so incredibly easily. It usually props up when candidates write left equals mid in a standard search. See, when the search space narrows down to just 2 elements, mid evaluates to left, and because you just set left equals mid, the range never actually shrinks, it just gets stuck forever. In a standard binary search, you avoid this completely by strictly updating left equals mid plus 1 and right equals mid minus 1. Your search range absolutely must shrink by at least 1 element every single iteration, no exceptions.
Now, here is a strict warning for you. If you are solving a lower bound problem, meaning you're looking for an insertion point or the very first occurrence of a target, you need a totally different half-open template. For that one, you use a strictly less than loop condition, and your right bound update becomes right equals mid. The golden rule to survive these interviews is this: pick one internally consistent template for exact target searches and one specific template for boundaries. Do not mix them up, or I promise you, you will drown in off-by-1 errors.
All right, so we've completely broken down the mechanics and rewired your foundational understanding of this algorithm. The big question now is, will your brain instantly spot that hidden monotonic condition in your next FANG interview? Don't just sit there. Head over to your favorite coding platform right now and put this stuff to the test. Challenge your newly rewired pattern recognition instinct. Keep practicing, stay focused on those frameworks, and I'll see you in the next explainer.